The strengths and weaknesses of mass flow and funnel flow. Good bin design is about making confident, science-supported decisions. And one of the most important decisions that you will make when designing a storage and feed system is choosing which flow pattern you're going to design for, mass flow or funnel flow. And to make a good decision, you will need to understand the cost benefit of each flow pattern, because each flow pattern does have its advantages and disadvantages. Starting with funnel flow. The big advantage of funnel flow is that you don't require steep sloping walls. With shallower hopper walls, you can get your desired storage with a shorter bin. Second, because material is stagnant along the bin walls and not sliding along the bin walls, you have less pressure on your bin walls, which means that there is less requirement for bin wall stiffening in order to hold the shape of the bin. Also, the stagnant material acts like a natural liner, and so there is less abrasion on your bin walls. The disadvantages, well, it starts with the nature of the flow pattern, which is a first in, last out flow pattern. This may be acceptable for some bulk solids, but others gain significant strength when they are allowed to sit at rest under their own weight. And the more strength the material has, the more susceptible your storage and feed system becomes to bridging and rat holing. The second disadvantage, and this is a big one, almost literally, the geometry required for reliable flow, specifically the minimum discharge opening, can be very, very big. And sometimes the minimum discharge opening is so big, it is bigger than the bin that you're designing. And the third disadvantage, and this is more of an operational issue, is that you should really be emptying out your funnel flow bin on a regular basis. Otherwise, the material that is sitting stagnant will never move and potentially rot or become rock hard. With mass flow, the big advantage is the first in, first out discharge pattern, where all the material is in motion during discharge. In particular, when we are talking about a difficult flowing material, it is often better to keep it in motion rather than let it sit still. The second advantage, and this one is really significant and maybe a little bit underappreciated, is that the geometry required for reliable discharge can be more reasonable. Specifically, the minimum discharge opening is often much more workable than if you were designing for funnel flow. But with mass flow, you need steep sloping walls, which means a taller bin for the same storage volume. And with material sliding on the bin walls, you have higher bin wall pressures, so a higher requirement for bin stiffening in order to maintain the shape of the bin, as well as more abrasion on the bin walls, which may mean more maintenance. Ultimately, a mass flow bin is a more expensive bin, no doubt about that. The last disadvantage is really about the fine print, but it is critical. To achieve mass flow, the discharge outlet of your storage bin needs to be fully effective. And what I mean by that is that material needs to be discharging equally from the full width and length of the discharge opening. And achieving this has everything to do with the behavior of the feeder. If the feeder pulls material unevenly or preferentially from the discharge opening, it will induce a funnel flow discharge pattern, regardless of how steep and smooth the sloping walls of your storage bin are. And if you get funnel flow in a bin designed for mass flow, you can find yourself in big trouble, because it is likely that the discharge opening will not be sufficient to overcome the bulk solids piping dimension, which means that the bin will be susceptible to chronic bridging and rat holing. So the choice of the feeder is important. Mass flow and funnel flow have their advantages and disadvantages. And as a first step in your design process, you should really be asking which one is right for your material and application. To learn more about why bins plug and the theory that underpins good bin and feeder design, visit the Kamengo website and download our white paper.